This morning we're going to do a little turning project in which we're going to turn a table lamp, which is a project that I did for fine woodworking about a year and a half, 2 years ago. I've now turned I think like 4 of these lamps, and this is the second one I've done for a club. They're kind of a fun project, and you'll be able to see some spindle turning. Most lathes aren't long enough to turn the entire lamp in one section. Vibration is directly proportional to stiffness and inversely proportional to mass. So cast iron has traditionally been a good material to build a lathe out of, in that we get a lot of mass, and the stiffness of this material is right. It's not real stiff. Recently, and might as well talk about this now with bandsaws. Recently, we've seen a number of lathes that are made out of structural steel and are sort of welded together. And traditional machine design said that was sort of a bad practice and not desirable because, of course, steel is very stiff, and it has a mass that's probably better than cast iron. So it has a mass, but it's too stiff, and it tends to transmit vibration. However, it's been found that a correctly designed weldment can actually yield a pretty good machine. The welds actually will arrest the vibration in a section, and the welds act like a crack in a glass, that you can't make a crack because the crack sort of cancels out the bite. Most furniture turners probably don't need more than about 10 inches in diameter. And again, that's a bit of a fooler in that if you take the advertised swing against the real swing is the distance over the tool rest, because you've got to get the tool rest under the spindle. So we've just ameliorated the swing of this lathe by an inch and a quarter, inch and a half is the height of this tool base, and that's times 2 on the swing. We're going to start with turning the base for this lamp, and Bob has done a nice job of gluing up some mahogany. So what we'll do first is find the centers. I often in my own shop use a metal worker center finder, which is like a thing that's at a 45-degree angle you can put on the ruler. And if you have a perfect square, it works fine. If you don't, it's not worth the powder to blow it to hell. Many times with wood, you're almost better just to very carefully draw the diagonals, and you'll come out in the right place. And there is very center. This is called a step center, and I like them a lot. A good rule of thumb is the rest should be about 2/3 the height of the material if you were doing an orthographic projection from the front. All right, I'm just about round now. Yeah. First time I ever tenons. I use a tool called a bedan. And it allows me to sort of rough that tenon in there, and I'm not going to reduce it too much further until I get this the way I want it. The reason being that if I make this thin, I'm going to set vibration in there, and I might as well get this perfect before I finish sizing the tenon. It's not protecting my important things. All right. Now we're going to start laying out some beads. And this thing, I don't know if anybody can see it, but it's kind of a very big bead here, 2 tight beads here, and then a little cove up at the top. One thing that is fairly important here is that we want the diameter here to be 2 1/8 inch right at the very series of cuts in here.
work is with a spindle gouge, and we're going to come to that circle right there. Now I'm going to make a nice shoulder here. And I'm going to dress these beads up a little bit. Eventually I'm going to go to a skew chisel here. But we'll show a repair, that this is completely repairable. I just put an undercut in that base. When this comes down on the other, that'll come down absolutely flush.
How are you coming into that?
Pardon?
How are you coming into that?
I set it there like that and just tip it down like that. Once I find that angle, I can just stick with it. Just sort of reduce this down to that diameter. And now we'll set our dividers to 3/8 for the size of the bead there. And that bead's a little above the bottom like that. We'll rough in our bead. Now we'll cut our bead. That's 2 1/8 up here too, and that's where we're going to conceal our joint. So we're going to bring this down to 2 1/8 inches in diameter. The roughing out gouge, folks, is that if you don't want to use a skew, you can turn this baby and just run it along like that, and you'll get a finish almost as good as a skew. And now we'll turn a nice big healthy bead there. Got to end up dead sideways there. Might as well just knock that material out of there while I'm at it. I don't hurry the tool, I give it time to cut. That's the idea of feed and speed. See how we're putting the taper on that shaft?
Oh, no. You think it's the one that is this is not going to demonstrate? It means everything. He cut Fred with me. Do you mind the grain before you
Not that good, actually. No. Good chocolate. The regular vanilla was the best. Were the guys' helmets on?
Your job is to hold that for a while. All right.
Yeah, we go. We got a lot. You have full face.
You know, anybody can make it right. It's to make it right after you've made it wrong. That's the real. I got it done before it can loosen up. And everybody watch, I'm just melding this shellac right into this point.
They gave you money to take a shot.
Almost.
No, this is what you would call garnet. It's the darkest of all shellacs. Wouldn't want to use anything else. Nice.
Wow. Very nice. It is. Beautiful.
Yeah, it's Cliff.
You know what you
Light cut. Right there.
That's like my wife wants
And now you just spin that until it starts to cut sweetly. And once it's cutting, you can do it with one hand. In England, this would be called polishing. Okay. And we got the wax cup. We got to drill the wax cup now. This is faceplate turning. Brain's running this way now.